In this video, we will start by providing a summary of the correlation between our electron groups and the hybridized orbitals predicted by the VS-EPR theory. We will then look at how we can incorporate our VS-EPR hybridized orbitals with our previous Lewis dot structures. First, as a reminder, when trying to determine the number of electron groups around a central atom, what we would do is draw out our Lewis dot structure and then count the different regions where we will find electrons, whether they be as lone pair electrons or electrons participating in single, double, or triple bonds. For our electron groups, it's regions of space, so single, double, and triple bonds all count as one region where we would find our electrons. If we have two electron groups, which would be two regions where we find electrons around the central atom, then it will participate in an electron geometry of linear. The hybridization scheme for this is sp. If there are three electron groups, then our electron geometry is trigonal planar, and the hybridization scheme would be sp2. For four electron groups, we have tetrahedral, sp3. 5, we have trigonal bipyramidal, sp3d, and for 6 electron groups we have octahedral with sp3d2. You can see that the correlation between the hybridization scheme and the number of electron groups is essentially the number of electron groups tells you how many orbitals you are mixing together to come up with your hybrid orbitals. For the 2, we have a single s and one p. For the 3, there is one s and two sets of p for a total of 3. For the 4, there is one s and 3p, which is a total of 4 orbitals. For 5, it's one s, 3 p's, and a d, which is 5 orbitals. And for 6 electron groups, it's an s, 3 sets of p's, and 2 sets of d's for a total of 6. In practice, the way that one would combine our Lewis structures and VS-EPR theory is as follows. First, you would start by drawing the Lewis structure. Then, you would count the number of electron groups around the central atom. You would use the VS-EPR theory to predict the electron groups around the central atom. Then, you could use the table 6.1 from our previous slide to select the hybridization scheme that matches the electron groups. An alternate way of doing this is to, once you know the number of electron groups, simply count up the number of orbitals, keeping in mind that you have a maximum of 1s, 3p, and 2d, and you would add them in that order. First an s, then counting through your p's until you reach up till 3, and then if you still need additional orbitals to mix together, you start counting through your d's. Next, when trying to figure out what type of bonds you might have, we could sketch the atomic and hybrid orbitals on the atoms in the molecules, showing the overlap of the orbitals. This will give you the rough bond angles that one would expect from the VS-EPR theory. We can then label our bonds as being either sigma or pi, depending on what the part of the sketch looks like. Again, a sigma bond is one in which the orbitals are directly overlapping, and a pi bond is one in which the orbitals are perpendicular to the interatomic axes. They are perpendicular to where the primary bond is and occur through indirect overlap, typically via p orbitals.